Hi everyone, it's Mrs. Marcellus, and Pythagoras is here with me again today. In our last lesson, we looked at creating ratio tables. Today we're going to take that a step further and graph them on the coordinate plane, then analyze what the graphs tell us. Are you ready for this, Pythagoras? He says, you betcha. Today's learning objective. Students will solve problems by graphing proportional relationships on the coordinate plane and analyzing the graphs. Whew, boy, that sure sounds like a mouthful, doesn't it? Well, let's take a look. It's really not as hard as it sounds. We're going to graph the ratio tables on the coordinate plane. You're probably already quite familiar with the coordinate plane. The coordinate plane has the x-axis, which is the horizontal number line. This is the number line that runs left to right. The y-axis is the vertical number line. This is the number line that runs up and down. The origin is where the x-axis and the y-axis intersect. It is marked with the ordered pair 0, 0. This is where you start whenever you graph ordered pairs on the coordinate plane. An ordered pair is used to locate a point on the coordinate plane. When you are graphing a point on the coordinate plane, you start at the origin and then you go to the x-coordinate. The x-coordinate corresponds to a number on the x-axis. For example, if you wanted to graph 3, 6, you would first go to 0, 0, and then you would move over 3 on the x-axis. This matches the x-coordinate. Then you would go up 6 on the y-axis. This would correspond to the y-coordinate. In our first example, we are going to graph the table that shows the number of cats that can be fed for each large can of food. This table shows this information as ordered pairs. Our first step is to graph the ordered pairs. Then we will describe the pattern in the graph. As you can see, the table has already been completed for us. If we have 1 can of food, it will feed 3 cats. 2 cans of food will feed 6 cats. We would take 2 times 3 to find that answer. 3 cans of food would feed 9 cats because we would multiply 3 times 3. When we create the ordered pairs, the x-coordinate comes first, so that's the number of cans, 1, 2, and 3. That's followed by the y-coordinate, which is the number of cats that can be fed. If we are going to graph these ordered pairs on the coordinate plane, we'll first go to the x-coordinate of the first point, which means we'd start at 0, 0, and move over to 1 on the x-axis, then we would go up to 3 on the y-axis. Next we would go over to 2 on the x-axis and up to 6 on the y-axis. And finally we would graph 3, 9 by going to 3 on the x-axis and 9 on the y-axis. As you can see, it looks like if we connected the dots, the graph would form a straight line. Because this is actually a linear function, something we'll study later in the year, the dots should line up. If you're graphing one of these tables and the dots don't look like they're going to line up, then that's a clue that you've made a mistake in graphing. Next, we should describe the pattern in the graph. The graph shows that every can of food will feed 3 cats. Moving along to our next example, the table shows Jan's earnings for working 1, 2, and 3 hours. Graph the ordered pairs and describe the pattern in the graph. As you can see, hours is along the x-axis and corresponds to the x-coordinate. Dollars is along the y-axis and corresponds to the y-coordinate. If Jan works 1 hour, she earns $5. We go over to 1 and up to 5 and put our dot there. If Jan works 2 hours, she earns $10. We go over 2 and up 10 to place the second dot. If she works 3 hours, she earns $15. We go over to 3 and up 15. Again, you can see that it looks like if we connected the dots, this would form a line. To describe the pattern in the graph, we could say that the graph shows Jan's earnings increase by $5 each hour. Another statement you might make is Jan earns $5 for each hour she works. Basically, when you describe the pattern in the graph, you should make an intelligent statement of how the two coordinates, the hours and the dollars, relate to each other. In this problem, we're going to complete two tables, then compare them by graphing them. Brianna places 4 photos on each page of her scrapbook. Luann places 6 photos on each page. Make a table that shows the number of photos placed in each scrapbook for 1, 2, 3, and 4 pages. Since we're starting with blank tables, we're going to have to fill them out ourselves. The first thing we should do is fill out the number of pages in Brianna's scrapbook. Then we can complete the column with the number of photos. We know that there are 4 photos on each page, so we need to multiply the number of pages times 4 to get the total number of photos. If there is 1 page, she'll have 4 photos. 2 times 4 will give us 8 photos. 3 times 4 will give us 12 photos, and 4 times 4 gives us 16 photos. Then we write the ordered pairs. This is just a combination of the X and the Y for each number of pages in Brianna's scrapbook. We need to do the same thing for Luann's scrapbook. We fill in the number of pages, and in Luann's scrapbook, she places 6 photos on each page. So in order to find the total number of photos, we'll multiply the number of pages times 6. After that, we'll write the ordered pairs. The next step is to graph the number of photos in each girl's scrapbook. We'll graph Brianna's scrapbook in blue. If she has 1 page, she has 4 photos. 2 pages, 8 photos. 3 pages, 12 photos. And 4 pages, 16 photos. Let's graph Luann's scrapbook in green. On 1 page, she has 6 photos. 2 pages, 12 photos, 3 pages, 18 photos, and 4 pages, 24 photos. Next, we need to answer the question, what do the graphs tell you? There are many different statements you can make. One might be that Luann's scrapbook has many more photos in it than Brianna's scrapbook. You might say that Brianna's scrapbook will have less photos than Luann's. You might say that the number of photos in Luann's scrapbook are increasing more quickly than those in Brianna's scrapbook. Or you might say that Brianna's number of photos is increasing more slowly than Luann's number of photos. You might note that for each page in the scrapbook, Luann has 2 more photos than Brianna. When you are asked to describe the graph or explain what the graphs tell you, there are many correct statements. It just needs to be something that makes sense, is correct, and is an intelligent statement about the information. It shouldn't be something very simple such as both graphs go up. That doesn't tell us much of anything. This concludes our lesson on graphing ratio tables.